wonderful Prob Stats students. So this is what I do. I like to make little quiz help videos. I don't do it for unit tests, but on unit tests, you can always submit test corrections, ask for retakes, and earn those points. Okay, so never be afraid of your grades in this class. Just do that learning, do those corrections, and everything's going to be great. Okay. All right, I want to take the quiz. Our announcements page, it'll link to the lesson. That's like the beginning of the lesson, and then that's directly to the quiz. I just like to give you guys the opportunity to see it right away in many different places, as in many ways as possible. All right, I'm not viewing as a student, so it won't look the same. But if you were viewing as a student, it would just be a blank, and then up here, you would arrow through. So let's just go down to the quiz. But look at the wonderful learning activities. Make sure you use those. Can't emphasize that enough. So far from the lessons I've worked through, besides the GeoGebra tasks, I really do like how things are going. Nice. Well done. So over here is your classmates. 4 of you guys have taken them already. There's the distribution. Please just always, if you're not happy with your score, just ask. Okay. So the standard setting is for 1 attempt, and that's because there aren't multiple variations. So I won't just automatically give 2 attempts when there's only 1 variation. I want you to try it without thinking, oh, I'll just click, 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 and then I'll take a retake. Does that kind of make sense? Because that isn't as beneficial as trying your best, saying, hey, Mrs. Reynolds, can I have a retake? And then retaking it. That is better for your brain and for learning. Okay? All right, type of fruit. Is it categorical or quantitative? Well, as you can see, it's highlighted in green as categorical. In college, we had tended to call that qualitative. It was a qualitative variable because it described a quality of the data, not a numerical amount of the data. So type of fruit is definitely a category. It's not a number. Not saying that numbers can't be categories, they can. And in class, we talked about how zip codes, they're numbers, area codes, 928, right? They're numbers, but they aren't a real numerical value. They are, but they're a category. It's not 928. That's not what they're saying. They're saying my area code is 928, and it's a category where we put all these other phone numbers in. So it has nothing to do, we're not going to add it, we're not going to find the mean, we're not going to find the average, we're not going to find the range. Because if I have a 480 to a 928, that doesn't make any sense. That's not the range of area codes. So there are some numbers that are categories, but typically they won't be. There are some, but typically if it's numerical, like a count, that's going to be a quantitative data point, variable. Okay. Question 2, let's see if I can go slower. Variation 1. Is this quantitative variable discrete or continuous? Discrete. Discrete basically means there's going to be gaps in your numbers, meaning you can't have a continuous count or a continuous amount down to the small number. So let's scroll down a little bit. Well, there you go. It's not letting me scroll small enough. Do you see how jumped? This was discrete scrolling. Just kidding. What I mean here is see how I can't just, it's like jumping, like boop. It's still continuous. See how it doesn't actually jump up like I don't know. Okay, it's still scrolling even though it's a quick scroll. It doesn't just cut, jump. We're still seeing the whole screen because it's a continuous scroll. So that's kind of what is happening with numbers. Income. Your income isn't continuous, right? When I get my paycheck, it's usually on a Friday and it's all at once. Boop. $100. There you go. Boop. It's not, a half of a fraction of a penny up to $1 and then all the numbers in between. Because think about all those numbers in between a penny to $1. on a number line, if I were to try to list all real numbers between 1/10 or 0.1, no, 100th, that's a hundredth, 0.01, the name of that number is 100th because that's the hundredths place. If I were to try to list all of these numbers, all real numbers, there's actually infinitely many. That's a different type of thinking, but it would be continuous. And in order to have a continuous income, the bank or my employer would have to slowly be paying me all these infinite amounts until they paid me my final amount right there. And it just, I don't know. You think about that, think about income. You get paid in chunks, so there's gaps. Your income can go up, but it doesn't go up continuously, right? We don't go from $1 to 1.000000001 and then 1 and 10 cents. We go from $12 an hour up to $15 an hour, up to $20 an hour, up to salaried positions where you get paid yearly. And then those chunks, they go in on usually Fridays. So we have a number here, or maybe this income, this person's income could be a certain amount, and then different types of income, but they'd be discrete. See how there's gaps in data. All right, I'm going to provide some help with that because that's a really big concept. And even in college, even for master's degree, statisticians, understanding when something is discrete and when something is continuous can be a big idea. All right, let's keep going. Is this categorical variable nominal or ordinal? Okay, nominal, no real order, just a name, just a description. Ordinal, just how it sounds, ordinal. Is there an order to it? Is there an implied order? So if we have police officer ranks, which I don't actually know them. Oh, did you see that? What are the, right when I was trying to just figure out what they were, police officer ranks in order. Oh, it already kind of helps you that there's an order to them. I'm going to go back to this one. So there's a police detective, police sergeant, police lieutenant, police captain, chief of police. So these are categories, right? Boop, 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 boop. There's an implied order to these categories. Oh, look, there's even stripes. That's cool. So a police officer has different ranks right here. Sergeant 1, Sergeant 2, Detective 1, Detective 2, Detective 3. So this would be ordinal, and it's because there's an implied ranking system in these categories. It's not the same as LAPD or San Diego Police Department or Yuma Police Department or Phoenix Police Department. Those would be nominal categories. There's not an implied rank. They may want to say there's a rank to the different police departments, but for statistics purposes, there wouldn't be. It would just be the names of the cities where the police department is, and there is no rank in cities unless you go list it in a certain way, and then that's not necessarily the category that's the rank. It's some other information that's the rank. Population, income, whatever. Okay? Think about that. Ask those questions. Definitions, heavy in probability and statistics. Lots of new definitions that you may not have seen before. Not too complicated, but whenever you're learning new vocabulary, it takes a second for it to sink in, right? Okay. A 4-year college student completed the given survey. Which variables are categorical? Well, categories, age, 19, right? Academic year, sophomore. Height, 5 feet 8 inches. Gender, female. Age and height. Age is numerical. We could take the ages in our classroom and do math on them, right? We could find the age range, maybe 15 to 21. Well, I'm 36. So of students, we could do total age of people in our class. We could do the average age of students in our class, so we can do math. So age is definitely numerical. Height, same thing. We could find the average height. We could find the range of height, our shortest classmate to our tallest classmate. We could do math on these. So they're definitely quantitative variables, right? Numerical numbers that we can actually do math on, numbers that aren't categories, say like zip code or area code. Academic year and height. Well, academic year 1, 2, 3, and 4, they could be numbers, but they're still categories. And you can even see how they didn't say second year, they said sophomore. So you can kind of see how categories of numbers, they describe it. It's a quality. It's not a actual number representation, right? Height is definitely numerical. It's definitely quantitative, which is your vocabulary word. So these two, you can't pick this one because one is a categorical variable and the other is a quantitative variable. Height and gender, same thing. Height is quantitative, gender is categorical. Finally, you pick this one, academic year and gender, because they're both categorical. Does that make sense? Okay. Height is continuous, by the way. Age is also continuous because you can't go from, say, being a baby to 1 year old, right? You're going to go from being 0 minutes old, and then you're going to have minutes, seconds, all of it in between. So even though we talk about our age as chunks of number, it's still considered continuous for most things. Obviously, with statistics and probability, we're going to have to read the problems. That's something that is always true, actually. Okay, the next thing is height is also continuous, right? I don't just go from 5 feet to 5.5 feet. We don't jump it. We go through all of the values until we reach our height, right? You're born a baby, but even inside, when you're becoming a person, you are growing from very, very small, but there's never a jump. Boop, boop, right? You start really, really small, and then you're just growing, growing, growing. When you come into the world, or however long you are, they think they do length, they don't do height, and then you just continuously grow from there. There's never a jump. You never jump up. Not even the Hulk, when he grows, does he jump sizes? He still goes through every possible size up into that point. I don't know. Hopefully that's starting to make sense. If not, check out Crash Course. They're awesome. I'll start linking them in our course for support. Which statement correctly describes the graph with respect to the terms categorical and quantitative? Categories and number representations. So let's talk about it. I already see some categories on here. What are the categories? Blood types, yes, A, B, and O. So blood type is categorical. Blood type is categorical. Great. Perfect. It's not quantitative. So we already know those two are not right. This is not right. This is not right. One of these two has to be right. Clearly you can see which one. But now let's read it. Blood type is categorical and the proportion of each type is categorical. No. This chunk, the blue and the red, the orange and the green, even though there's no numbers in there, that represents a numerical value, a quantity. So whatever this blood type circle graph is representing, however many O in this is, there's a number there in relation to the whole. So that is a quantitative variable. You can do math on it. And in fact, there would normally be percentages representing this percent of O, percent of B, percent of A, percent of AB. It could be something like a blood drive. This was how many different types of blood they captured, calculated, collected. There we go, that day. So we were looking for this selection. Blood type is categorical, and the proportion of each type is quantitative. All right. Let me know if you remember how circle graphs work, how proportions work, where percentages are coming from. Part to the whole. Percents are always written with a denominator of 100, percent per 100, but it's just a ratio. It's still an equivalent ratio to whatever these amounts are in the data. Hope this helped. I hope you enjoy this class. Again, always reach out if you ever have any questions. Thanks for watching, and I will see you later.